Hey everybody, welcome back to Organic Chemistry. My name is Todd Rothman. In this video, we're going to go over the final problem set for aldehydes and ketones. Okay, so this is actually section 8 and 9 problems combined. All right, so basically for section 9, the whole video is just doing these problems number 25 through 34. And by the time we're done with these problems, you'll have a very good handle on this chapter. Now, in addition to these problems, I plan on doing some other problems that I found from lecture notes, and we'll go over those too, but not in this video. I'm going to do that after we're finished with all the chapters, the aldehyde, ketone, and carboxylic acid and derivative. Then I'll go over some additional problems that I found in the PowerPoints in your lecture that I think warrants our attention for your exam. Okay, so we'll do that as well. Now just please remember, number one, I hope that you tried these problems out, and if you haven't, then I recommend that you pause the video and do that now before we solve it together. Okay, and when you do that, remember that you have to skip the nitrogen related information for this exam. So 25 A, 26 BH and J, 27, 28, 34. So all these problems here, 27 HI, 28 E, and 34, the bottom left, make sure, don't even bother, you don't know how to do that. So in general, remember, anything that has a double bond to an N or a single bond to an N but a double bond to a neighbor carbon, these are things that we don't need to know for this exam. It's called the imine and the amine. So if you happen to see things like this, ignore it. The only exception is a nitrile. You have to know, you do need to know C triple bond N. That is a nitrile, and that you need to know. Okay? So that you do need to know, but you don't need to know, do not need these down here. Okay? Not until exam 3. Alright, so that's it. Hopefully that's now clear, and let's get started. So the first problem is very simple. It's just a flow chart. Now again, A we can skip because this one here, skip until exam 3. So that's making what's called an imine, which we don't have to worry about. So don't worry about that one right there. But for B, that is something we have to know. This is from last semester. Last semester we talked about epoxides, right? And so with epoxides, I hope you remember I taught you guys BLAM, and that's to help you remember how to consider opening up an epoxide, right? So we said that last semester, this is all review, that there are two ways to open up an epoxide. Either the lower degree side or the higher degree side is going to be attacked by a nucleophile. And the way that you figure out which one the nucleophile goes into is all based upon whether it's acid or base over the arrow. So if that's a hydroxide, it's base. If it's H+, it's acid. So acid means more substituted. That in turn means that this water down below is going to go to the more substituted, while this oxygen winds up leaning away to the less substituted. Now it turns out it really didn't matter for this problem because it's the same thing twice. So you didn't really have to know which one or where they went, but if they gave you an alcohol, you would have to know, right? So water right here comes into the higher degree, and then the O from the epoxide leans to the lower degree. That's what acid does. BLAM, acid, more substituted, higher degree. All right, so now what we did is we just simply opened this up from an epoxide to an alcohol, a dialcohol, and now we're adding a ketone in, right? This is our semester stuff, new material. And so what we were told is that the carbon that has the carbonyl, it can be attacked by oxygen, right? And if it's alcohol, it's attached twice. So this right here with acid, H+, which in this case is H2SO4, we can have this come in and open this up and get protonated and so on. Now, we're not going to do the mechanism, we're just doing the prediction. So we know this comes in, but also this one is going to come in, right? So if we do the mechanism for that, we would protonate the carbonyl first and then bring one of the two alcohols in, and then the second alcohol comes in, and you want it making the acetal. I cannot emphasize how important it is that you know how to draw out the answers in addition to the mechanisms, because people that are not comfortable with the answers only, they waste a lot of time on this exam, and they usually complain that they didn't have enough time. All right, so if you look at this problem and you have to do every step, that's a problem for you. You should know how to do every step, and I encourage that you practice that. But you also, equally important, have to know, okay, I have a ketone and I have two alcohols, right? Alcohol twice here and here, so I know it becomes an acetal, right? And that's what I did. The red carbon is now an acetal carbon. The double bond O carbon now has two ORs. You have to know how to do that. Otherwise, you're going to waste a lot of precious time on your exam. All right? So I'm not going to focus on mechanism for this problem, just the overall process, okay? So for C, we have the first step, which is just using PCC, right? This is a partial oxidizer, right? And that means that no matter what this alcohol is, whether it's primary or secondary, it becomes just double bond O. It doesn't go any further. So in this case, it becomes just double bond O, right? And now just remember that alcohols that have one H on the carbon that holds it always becomes double bond O. That's it. But if it had two H's, it would still become double bond O. It wouldn't be anything more. It wouldn't be a carboxylic acid, right? That's the key difference, right? I want you to make sure you know that. So if I have an alcohol like this and it has two H's, it's primary, right? If I write PCC, it becomes double bond O. But if I don't write if I write CrO3 or some other chromium or KMnO4, that's hot. Okay, if I do that, then because it has two H's, it doesn't just become double bond O. It actually becomes double bond O, OH. See the difference? So PCC, no matter what, is going to become partially oxidized. Now let me show you the same example. If I have a carbonyl like an alcohol like this, and it has one H on it, it doesn't matter. PCC or CrO3 or KMnO4, it doesn't make a difference. They all just become double bond O. See that? Because there's only one H on the oxygen to remove. So oxidation is dependent upon the number of H's on the carbon that holds the OH. If it has two H's, it's oxidized up to 2 times. If it has one H, oxidized 1 time. What if it has no H's, right? Then no matter what you use, there's no reaction. It stays the same. Why? Because there's no H. So that's proof that it's all about the number of H's on the carbon that holds the oxygen. Okay? PCC is our tool that even if it has a lot of H's, it still only oxidizes once, double bond O. All right, that's hopefully a good review for you from last semester, because that is really important that you know that. Okay, now what? Well, from here, we can do Grignard. And so this is ethyl magnesium bromide. Well, all we're going to do is have the ethyl. Remember how this is a carbon that's negative? That's what it means to be next to magnesium. So this is going to go in. This is going to open up and then get protonated by step 2, water. So the answer is, actually, let me fix that. So the answer is like that, and this is now an alcohol, right? So the blue carbon is now an alcohol, and it just got added to it an ethyl, and that's the answer right there. Okay? Okay, now for D, we're not starting as an alcohol like we did in C. Now we're starting as a carbonyl, but we still have another thing, an alkyl lithium instead of magnesium bromide. They do the same thing. So just like above, ethyl is going to go after the carbonyl carbon. And this is going to open up. And you get to O minus, and then ethyl, but then H plus is going to protonate it. And I wrote H plus. Notice the difference? They're the same. They're really the same thing. If you write H plus or H2O, it means the same thing. Okay? If I write ethyl in a line formula or in a shorthand or an abbreviation like that, in the condensed formula, same thing, right? So just don't get confused. These are really the same exact reactions twice. The only difference is PCC up above, not below. But now I want you to keep in mind one other thing. In your next chapter that you're learning about, not carboxylic acid and derivative, chapter 17, but chapter 18, we're going to learn that sometimes you can put the carbon on the beta carbon. The ethyl can go there because of resonance. This can go up, this can go up. So if there's a double bond, if there's an alpha beta double bond, alpha beta